All right, we're at the top of the hour, so we can go ahead and get started. Hello, everyone, and thank you for joining the webinar today as we introduce our new HE500 Series product line. My name is Brent Patrick. I'm the Senior Marketing Manager for Scale Computing, and I'm joined today by Dave Demlow, our Vice President of Product Management. I have just a couple of quick housekeeping items before we pass the ball to Dave and get started for the day. The first thing is that the webinar will be recorded today, so if you have to jump off at any point, no worries. You'll receive a copy of the recording in your inbox within the next 24 hours or so. Also, on the bottom right-hand side of the screen, you'll notice a Q&A box. This is the best place to ask any questions throughout the webinar. We've pocketed some time at the end of the event for Q&A, so we'll get to those questions toward the end of the event. All that said, I will pass the ball over to Scale Computing's Vice President of Product Management, Dave Demlow, to get started.
Thanks a lot, Brent, and thanks everyone for joining. Today, the agenda, we're going to talk about edge computing and industry trends in IT infrastructure overall, Scale Computing's journey to the edge, why we're focusing there, why we're differentiated, and then the main topic here is we're going to introduce our HE500 series, which is our first purpose-built edge computing product line, really driven from the ground up for these highly distributed, very efficient edge use cases. So let's talk about edge. Why edge computing? This is a Gartner definition that kind of relates Internet of Things and defines edge in that terms. The network of physical objects that contain embedded technology to communicate and sense or interact with their internal states and the external environment. That's a lot of words. To me, that means the edge is where IT infrastructure touches humans, touches things, touches information and gathers information to be stored, to be processed, to be analyzed, close to where the data lives. And that's kind of a recurring theme in edge is with the increasing amount of data created, it's very, very important that that data collection happens consistently, happens reliably, happens with high availability, and that the processing and analysis of that data can occur at a cost-effective place. So here's some trends and some quotes relating to edge and the next next generation of IT infrastructure. If the 2010s were the decade of cloud computing, the 2020s will be the decade of micro data centers at the edge, and we'll talk about some concepts of micro data centers. In terms of data that this represents, if around 10% of enterprise data center is created and processed outside of traditional cloud or data center now, by 2020, that's expected to reach 75% of all data. So that really, to me, shows why there is a need for edge computing, why you can't centralize and store and process all of that in a corporate data center, in a public cloud exclusively, why there's a need for kind of tiers of storage, tiers of processing. And then just in terms of business side, a lot of dollars, a lot of investment in technology is being spent right now to address this growing need, the number of devices, the amount of data that's proliferating. Here's kind of a visual view and some of the use cases. So really you can view the edge as a high-performance bridge to other forms of computing that you're familiar with, whether it's centralized data center, whether it's public cloud, private cloud, and as we look in this space, we really see needs and opportunities, a little bit of differences here and there in a whole lot of different vertical markets, everything from retail, which if you look at our website, we've got some recent case studies of retail edge deployments, thousands of grocery stores, for example, and some of the needs that they had, healthcare, banking, smart buildings, smart cities, transportation. Along all of these, there's certain kind of common use cases like video surveillance and video analytics that are driving a lot of the capacity and compute requirements, but all enabling new use cases in many opportunities where things that weren't possible to be done are being done through this edge computing infrastructure. So what are some of the needs? First and foremost, edge requires simplicity. Most edge sites have no IT staff, and if you're familiar with scale computing and kind of our legacy, we've always focused on simplicity and use cases where maybe there's one or two IT staff that are responsible for a handful of sites or a single site and kind of jack of all trade administrators. So we have a lot of experience in providing that ease of use, of simplifying and automating systems and automating IT. providing self-healing infrastructure. One of the key things we developed and perfected in the hyperconvergence space is IT infrastructure that can monitor itself, take corrective action, monitor, physical hardware, drive failures, drive errors, that might lead to a predictive failure, monitoring networking events, things like that, and then being able to take automated action to correct the system, to tune the system, to meet the application's needs, to meet the customer needs, to keep those applications up and running. Another unique needs of edge, particularly when you look at multiple site edge deployments, which is one of the areas that we're focusing on, is the needs for rapid, quick, standardized deployment, not requiring a specifically trained IT staff of, let's go implement storage, now let's go back and implement virtualization stack and so forth, as well as once it's deployed in all these remote locations, being able to manage it remotely with ease and do things like push out infrastructure upgrades without, scheduled downtime or sending someone on site every time that there's a software update or things like hardware failures. This will actually kind of go and illustrate, some of the kinds of things when you look at edge locations, which, often are counted in dozens, hundreds, or even thousands. Any kind of cost, whether it's, 10 minutes a day of managing multiple systems, coming in the morning and checking the server infrastructure, now checking the storage infrastructure, now checking the network, anything to do to simplify even as little as, 10 minutes of management time a site can add up to a 40-hour work week across a large organization. And then you get into other things on, deployment time and upgrade time for infrastructure. Resource requirements, and we'll talk definitely more about this, being able to operate very, very efficiently and get the most bang for buck out of hardware resources. So being able to use every byte of RAM, every CPU cycle for application processing as opposed to care and feeding and keeping the infrastructure lights on, so to speak, adds up to a lot of cost, a lot of additional RAM and cost and maintenance. And then, really what most of this is about outages. So an outage at even a single site can cost thousands of, in many cases, hundreds of thousands of dollars in lost businesses. And then the cost of, physically transporting, rolling a truck out to a remote site to resolve certain issues. Any one of those that you can prevent through planning, especially across a large distributed organization, the costs just add up very, very quickly. So as far as scale computing, just a little bit about us for those who may not be familiar and kind of our journey towards the edge computing. We were incorporated in 2008 and in 2010 released our first built our first hyperconverged product, adopting KVM as the hypervisor for our hyperconverged software. We fully launched the HE3 system in 2012. In 2013, we partnered with Google Compute Engine and launched with their KVM hypervisor to deliver virtual machines and disaster recovery as a service coupled with the HE3 platform. Just in terms of KVM, in terms of its adoption as a hypervisor, there's been many well-publicized cases of large customers who are standardizing on KVM, the built-in Linux hypervisor, as their virtualization platform of choice. As of 2016, we had 1,500 customers that had adopted Scale in the hyperconverged space, and at the time and still today, continue to be the #1 KVM-based hyperconverged vendor. In 2017, we won one of the largest hyperconverged deployment, which happened to be a retail infrastructure, a largely distributed edge type environment. And then in 2018, we launched the software stack that we had co-developed for that deployment, which includes our normal hyperconverged stack, our intellectual property in distributed storage and redundancy, as well as a lot of the management and orchestration pieces that we had developed to be able to manage a largely distributed site organization and launch that as HE3 Edge, being the software stack focused on edge computing. And then today, basically, we'll talk about our first appliance-based version, the HE500 Series, which is, again, kind of the result of, the right form factor, right cost, right flexibility, and right reliability using that software stack for these distributed edge environments. So a little bit of background on architectural efficiency and particularly how different hyperconverged architectures lend themselves to edge computing. So on the left, you see what's called a virtual storage appliance architecture. And for those of you who might say, well, hey, at first glance, that kind of looks like a fan. It kind of looks like the old way 3-2-1 architecture of building distributed virtualized infrastructure. You would be right. And in that model, which many hyperconverged products use, they actually did start as what would have been the code that ran a storage device, a SAN or NAS array. They put that into a virtual machine, ran it on the hyperconverged nodes as a separate application that, basically was your software SAN, actually uses iSCSI or NFS storage protocols, connects back into the hypervisor as a separate application, and then provides the storage and storage redundancy. In that architecture, it's not uncommon for those virtual storage appliances to consume anywhere from 70 to several hundred gigabytes of RAM, depending on services that they're providing, and consume the capacity of a lot of dedicated compute cores because they're basically running as a separate application at that point. You need to provide resources and carve out those resources strictly for running the storage stack. As opposed to HE3, we've integrated our intellectual property, our storage stack, directly into the operating system kernel, what we call hypercore. So that runs the hypervisor layer, that runs our storage layer, that runs all of our management pieces, and consumes less than 12 gigabytes of RAM in a 3-node cluster, and just a fraction of a CPU core to provide the same amount of work. So that's great. That's cost efficient. When you look at that in an edge environment where you're now trying to write size hardware for just the applications that you're running, across these hundreds or thousands of sites, that's where it really makes a big difference. So if, say, for example, you took a hyperconverged compute node that had 64 gig of RAM, and the first thing you have to load on that is a virtual storage appliance to provide the storage stack and the management and so forth, and that virtual storage appliance takes up 24 gig of RAM, you've cut your available resources for just that one node down to 40 gig, versus on the right, HE3 operating system platform taking about 4 gigabytes of RAM, leaving that out to, leaving the remainder for applications and workloads. If you try to do that on a more cost-efficient and platform, like a 32 gigabyte RAM platform, which we are actually announcing and offering, you'd be kind of silly. You'd have 8 gigabytes of actual RAM to do any useful work. Most of the resources, from a RAM perspective on that node, would be consumed just keeping the lights on and providing those basic infrastructure services. So that's just one example of where the efficiency really matters. There's also parallels in terms of CPU utilization, storage, and so forth. But this really makes the point where in an edge environment where you're trying to minimize cost, right size for your particular applications, efficiency really matters and adds up across a lot of sites. So here we are introducing HE3 Edge, which is a set of software and hardware products that we're announcing here, focused on edge. And so kind of going through the hierarchy, you've got your things, your Internet of Things that are doing your data collection and so forth, or whatever kinds of edge applications. Again, this can be video surveillance, this can be anything that is run best on premises, close to the data source, where fast processing, fast decision making, without going a round trip over a unreliable network to a cloud and back and so forth is important. So we have these nano data centers, these new edge devices, both hardware and software stack that are optimized for that environment, for that form factor, which we'll go into more. You've got the core cloud type stuff, whether that's public cloud or an on-premises private cloud that is providing kind of all the centralized resources. This is an area where HE3 has been involved since the beginning, and then we kind of have in between where this fog layer where it might be bigger resources required, higher compute environments, but still some type of distributed nature, and scale provides nodes and software options that really cover that full range of solutions. So on to here, the HE500 series, which we announced is right size. So we do offer small form factors for edge. And this, by the way, is the first of a series of products. We offer, expect to offer other edge product lines, hardware right size, different form factors. But here we have a small form factor 1U node as well as some tower configurations, very affordable resource options. We looked very heavily at the kinds of workloads being run in many of these edge locations. In a lot of cases, it's just basic data collection, simple IT infrastructure, DNS, DHCP, Active Directory types of things that don't need a lot of heavy compute resources. This configuration is micro data center ready, which means we actually have worked with partners to offer this as a pre-configured, pre-racked in some cases, pre-cabled, hyperconverged cluster that can be easily deployed and rolled out en masse to a large number of locations. You get efficient performance, so we'll go through the lines. We have everything from hybrid flash and spinning disk to all flash options to all spinning disk options, depending on the capacity, the reliability needs of the application and the site. We went through the very efficient memory usage and the fact that there's no VSA overhead, so the vast chunk of the resources in these nodes are available to run your applications. And then from a software capability, it's full featured. So this HE3 Edge software, there's no scale down of features. It's our full virtualization stack. The nodes are actually compatible and interoperable with our existing series, both even within a cluster, but probably more commonly, we'll go through some of the architectures, where it may be a replication partner. Maybe you have some of our higher end data center type class clusters at a central location. That's a replication partner for many edge sites or pushing out updates to many edge sites. So we made sure there was full compatibility with our product line. In terms of the full-featured software, there also are a number of, as I mentioned, very specific remote management features that are available to help you manage these very large deployments from a centralized location. So on the pricing, and scale has always been very outward of, here's the price, so you can figure out, which of these fits your form factors. You can see they're all around $5,000 a node, and that goes everything from all flash to all spinning disk to hybrid. So you can kind of pick what the storage needs you have, but these are all the options. So there's basically the 1U rack mount or the tower configuration, which we'll go through some of the special cases of the tower configuration. Intel processors, several different options, and these are because of the deployment size. These are generally fewer cores, faster cores, but suitable for a number of these edge locations. RAM, either the 32 or 64 gigabyte options, and then various storage configurations, everything from all spinning disk to all flash to tiered configurations that are available. But a 3-node cluster with a MSRP just over $15,000 starting at price for these. So some use cases, we see a number of them. We do see applications for this in small to medium-sized businesses. When we started off HC3, our initial product lines at the time, many years ago, actually came with the 32 gigabytes of RAM, and we had many customers that was more than sufficient to run the 5 to 10 to 15 applications that those customers had. Given especially the scale-out capability of hyperconvergence, you're not limited to 3 nodes. You can add down the line. So we do see an application for this for small to mid-sized businesses getting a 3-node cluster, full high availability, built-in backup and recovery capability, the ability to replicate off-site and so forth at around 16.5 MSRP. There is also the potential to run a single node or single system in the tower for off-site and replicate those back to a central location. So there are many use cases, both in small and mid-sized businesses and distributed, and MSP for that matter, where a single node or server on premises running the applications, but knowing that you've got that built-in replication and failover capability to switch over to another location fairly quickly in the event of a full system or full site failure. So another case, and this is really, where I think the edge part comes from, is what we call distributed enterprise or distributed hyperconvergence. And this is where you're talking anywhere from tens to hundreds or thousands of sites that require quick deployment, ease of use, simplified remote management, limited to no on-site IT staff on site. And just as a note, when we talk about the no IT staff or minimizing, truck rolls or visits to the site, inherent in HC3 in our storage capability is for probably the most common thing you would expect in a particularly hybrid or spinning disk environment would be a case like a disk drive failure. And in a case like that, HC3 automatically detects, a disk drive failure, removes it out of the storage pool, reprotects all the data so that, every data remains full redundancy on the remaining nodes. And there's actually no fire drill, no immediate need to, run out to that site and replace that drive in any particular time frame. We actually do have customers who kind of schedule monthly or quarterly visits, and if in that quarter 2 drives have failed, they go out to the site with the 2 replacement drives, they pop the bad ones out, pop the new ones in, and there's no degraded state during that time. All they're doing is basically replacing the capacity. We've already removed those defective drives from the pool, we've reprotected all the data, everything's fine for additional failures, for full redundancy. And that's been a capability that many of our customers have utilized in the past. Definitely applies to some of these sites that are more distributed, harder to get to. There's not a need in those cases to run out and replace kind of common issues on a regular basis. And then another one is managed service provider deployments, or MSPs. So Scale partners with many MSPs. We have specific programs that are targeted to work with MSPs and let them offer infrastructure as a service, disaster recovery as a service out to their end customers, and we provide them support and hardware directly. But for MSP deployments that might be under 100 users on site, might have anywhere from 2 to 6 virtual machines with 1 to 5 terabytes of storage, either a 3-node cluster on site if they're looking for that level of availability and automation, or even the single node use cases we've talked about, replicating back to either the MSP's own data center or possibly leveraging our Google Cloud Unity platform and using the Google Cloud as a disaster recovery location or failover type case. So another use case overview, in this kind of an edge computing case. This is an example of a 3-node HE550F, which is an all-flash system. And often we do see in these distributed locations customers that, A, don't have the big capacity needs, so an all-flash system is plenty of capacity and just eliminates the reliability of spinning rust. And replacing that with all solid-state storage can be very cost-effective and just another availability boost and reduce those more frequent disk failures that you would see on spinning disks. But in this case, this addresses the need where there's a downtime cost associated in the environment, so looking for high availability, looking for automation, so automated failover, has a low capacity requirements, and we often see these in what we would call a retail edge environment where they're running an Active Directory domain controller, they're running some file and print or collaboration servers, they're running some POS, maybe running inventory management, and possibly even, and these are some of the use cases that might drive you to a hybrid node. Maybe they're adding video surveillance, so they do need higher capacity for those video archives, or running additional applications that have a higher capacity requirement. I mentioned the tower configuration, and really one of the primary use cases that we released the tower configuration for is actually as a high-capacity backup target. So in this case, it's the HE500T can be configured with either 4 or 8 drives and up to 8 terabyte drives, so you can go up to 64 terabytes of raw storage capacity in a tower configuration, which makes it on its own a very good backup DR replication server for a number of our products, not only the HE500 series, but into our kind of flagship HC1200 and basically HC1000 series product line, using that as a backup target, leveraging our built-in backup and restore capabilities, both single file restore and full VM recovery. The tower does have compute and RAM available to run workloads, so you can actually, in the event of a disaster, spin up your workloads directly on it. And then the tower configuration, eliminates the rack requirements. So putting it in a secondary location in a data closet is perfectly acceptable. And then so here are, just kind of some broader deployment examples, very common where we see a central core location that might have a central cluster where they provide centralized management. That's where they run their NOC. That might be where they, run our central management capability, log collection, whether they're using, Splunk or some other type of management tool to gather logs from the remote HE3 systems, from other types of applications and systems. Using that for deployment of test and dev for new applications, new application versions in the central site, and then have an array of edge sites that may vary on 3-node clusters where you need high availability, single nodes where you just need kind of that edge endpoint that can do local authentication, but doesn't have the same downtime cost if the whole site is down, or if you have to fail that over to the centralized site and access it remotely. But we can support that mix, and we can support it across a very large number of locations very easily. So that's the end of the presentation. I want to thank everyone for their time. And Brent, see if you're online. I was if there were questions that came in.
Yeah, we have some questions. Cool, Dave. Thank you for that. It was really, really clear and helpful. So the first question that we have is around deployment. Can you deploy one server alone? What are the limitations there?
One server alone. So yeah, that would be the single node configuration. So any HC3, well, I will not say anything. Most of the HC3 nodes, and we have a compatibility matrix that says which ones can't, but can be deployed in the single node configuration. And in the single node, as opposed to doing data redundancy across the nodes in a multi-node cluster, we provide basically kind of software RAID. So there's data redundancy within the single system that does have an obvious impact on the capacity that's available. And generally, the limitations there in terms of storage are, with some exceptions, they have to be all of one storage type. So they have to be either all spinning disk or all flash in the single node configuration. There are some exceptions, but it has to do with basically how many disks we have in each tier of these product lines to do the single node configuration. You'd either go with all spinning disk or all flash. And then, as I mentioned, we're providing data storage redundancy locally just on different drives within the same node. Some of the other, caveats are, from a support standpoint, we do require that those systems be replicated. So either that you're replicating them to another single node system, to another cluster, to an MSP provider, to the Google Cloud, our Google Cloud Unity offering, something like that, so that you do have redundancy for that at a different location, that there's a copy of your data stored elsewhere. The only other kind of operational thing that is just a natural effect of the single node system is because there's no alternate location within a local cluster to move virtual machines to. We can't live migrate anywhere. That we cannot do rolling upgrades, which are one of the really popular features of our HC3 clustered platforms, that when there's a software update, it shows up in the UI, and you just, with one click, we upgrade the entire software stack in one step across the cluster by orchestrating a rolling upgrade. So we'll take all the virtual machines off the first node, live migrate them elsewhere, upgrade that first node, move them back to where they were, and kind of go through an entire cluster, updating our HyperCore software, new software capabilities, new management capabilities without any disruption. In the event of a single node, since there's a live migration, you do have to shut the virtual machines down, do the upgrade, which is very quick with all the virtual machines down, and then power them back on. That would be one other, operational case, and then, the obvious that you don't have automatic high availability failover to other nodes in the system.
Perfect. Thanks, Dave. So the next question is, how can Edge be implemented in facilities that are, for example, 4-mile-long production buildings? Would they be centralized? Can you talk to that?
4-mile-long production building. I'm trying to picture that. It sounds like kind of a specific thing. I guess it does. It sounds like maybe that's a network question, or maybe an application-specific thing. If maybe it's possible that there are multiple edge devices within that facility, and I guess on one hand, depending on even the networking, they could be nodes that are clustered together. But I guess the key is, you know, as opposed to saying, well, you got to buy this really big beefy server, and maybe, you know, the way this particular facility is laid out, you would be better with 10 very small servers or 20. Or you know, it's hard to kind of picture the specifics here. We would be able to offer smaller devices that let you put the compute where it makes most sense. And like I mentioned, and again, we're not doing any product announcements here. Definitely, our plans are to continue, and probably if you've seen us around, you know, we've done some demos for proof of concepts on very, very small devices, like if you've seen a Lenovo Tiny device, which is kind of it's almost a VDI thin client, you know, kind of thing, little square, you know, 4 inches cube like that. We've done proof of concepts running HE3 Edge software on devices like that, or on an Intel NUC, for example. And we certainly are looking at additional form factors that make sense to deploy, you know, close to the data where they're important. And along with that, I forgot if this was manufacturing was specifically mentioned. We're also looking at, you know, other requirements like ruggedized devices, fanless, things like that for, you know, specific environmental constraints. So hopefully that answers the question, but otherwise I would suggest, you know, connect in with your sales rep, and then, you know, we can dig into the specifics of your use case there.
Cool. Thanks, Dave. A couple more questions. What version of HyperCore ships on the HE500 platform?
As of right now, it should be 8.3, I believe. 8.2 or 8.3, but in the 8.0 timeframe. But I think it's either 8.3 or maybe 8.4.
Cool. Is the HE500 limited to 64 gigs of RAM max on each node?
At this point, it is. That's a limitation of that current Intel architecture. So yeah, that is the maximum RAM that's available in those systems today. There are some enhancements to that product line coming out from Intel that may increase that in the future. But yeah, that's fully populated. All the DIMM slots available on those systems.
Cool. And there are a good mix of customers and non-customers on this call specifically. So we had one question relating to VMware and what version of VMware is required to run on the HE500.
Oh, the one you got rid of, basically. So yeah, if it wasn't clear, yes, our platforms all include our own version of the KVM hypervisor. There's no extra. There's no VMware licensing required, no VMware running, no Hyper-V. So the hypervisor, the storage stack, the management pieces, other VMware things you might, you know, the separate vCenter server that you have to run and manage elsewhere, that goes away. The management's all web-based, built right into the HC3 system. So no VMware required. And what we do, it's very easy to migrate existing virtual machines and workloads from a VMware or Hyper-V environment or cloud environment onto the HC3, and we have a variety of tools and services that can make moving onto HC3 super easy and simple.
Awesome. Well, that's all the questions we have, Dave. Thanks so much for the time. Thanks, everyone, for joining. And remember that we will send a recording of this webinar to your inbox within the next 24 hours. Thanks, everyone.
Thank you. Thanks.